In this video, we are going to be multiplying this rational expression. So notice that it's a rational expression because we have a fraction times a fraction, and each fraction has variables in both the numerator and the denominator. Now, there would be nothing wrong with multiplying straight across the top, 3y minus 9 times 4y squared plus 12y plus 5, and then doing the same thing on the bottom, multiplying straight across the bottom in the denominators. However, we will end up with an answer that's not fully simplified. It's going to be much easier both to do the multiplication and have a simplified answer if we simplify these expressions first. So the first thing I'm going to do is simplify by factoring. So I'm going to take this 3y minus 9 and look for the GCF, the greatest common factor, which would be 3. So I'm going to divide out a 3 or factor out a 3, and I'm left with y minus 3. And I'm going to do the same thing in the denominator. I see 5y plus 30. Looking for a GCF, a greatest common factor, I see 5. So I'm going to factor out a 5, and I'm left with y plus 6, because 6 times 5 is 30. Now I'm going to do the same thing with these trinomials over here. I'm going to factor them. First, let's look for a greatest common factor. In the numerator, I don't see anything other than 1, so that's not going to be helpful. Same in the denominator, I don't see anything other than 1, so again, that's not going to be helpful. I'm also noticing that both of them have an a, in other words, the coefficient on the y squared term is not 1. So in this case, I'm going to use the AC method to factor these. So I'm going to come over here off to the side, so I have a little bit more room, and look at 4y squared plus 12y plus 5. And the AC method says I'm going to take a times c, which would be 20, 4 times 5. And I'm going to look for factors of 20 that add to make 12. So let's see, I know 4 times 5 makes 20, but if I add those, it does not make 12. Let's see, what about 2 times 10? 2 times 10 makes 20, and I add those to make 12. So I'm going to take the 12y term and I'm going to split it into two terms, 2y and 10y. So let's rewrite this thing, 4y squared plus 2y plus 10y plus 5. And now I'm going to split it into two groups and factor by grouping. So in group 1, 4y squared plus 2y, I'm looking again for my GCF, my greatest common factor. And I see with the numbers, the coefficients, that would be 2. And with the variables, the greatest factor that's common to both y squared and y would be y. So I'm left with 2y plus, now what do I get when I factor 2y from 2y? Well, I'm left with a 1. Don't forget that 1. Okay, same thing over here. I'm looking for GCF of 10y and 5, and I believe that would be 5. So when I factor that out, I'm left with 2y plus 1. This is a good sign. I think I've done something right because I see that I have 2y plus 1 common to both of these terms. So now I can factor the 2y plus 1 out. And I am left with a 2y from the first term and a plus 5 from the second term. So it looks like 4y squared plus 12y plus 5 factors into 2y plus 1 times 2y plus 5. Now let's do the same thing in the denominator. And I'm going to change colors here. Let's come up here so I have a little bit more space. Let me get my pen again. And I'm going to do 2y squared minus y minus 15. Using the AC method, I'm going to do 2 times negative 15, which is negative 30. Now I'm looking for factors of negative 30 that add to make negative 1, which is b. So I could do 6 times negative 5. That would give me negative 30, but that's not going to give me negative 1. Oh, but what if I change it and do negative 6 times positive 5? That would give me a negative 1 when I add them. So I think those are going to be my magic terms. So I'm going to take that negative y and split it into a negative 6y and a positive 5y. And then minus 15. Okay, now let's go ahead and do my factoring by grouping. 2y squared minus 6y, I'm going to factor out a 2y. I'm left with a y minus 3. I'll go through this one a little bit more quickly. Over here, I'm going to factor out a 5. and I'm left with a y minus 3. Sorry, I'm running out of space here. Now again, this looks like a good sign. I've got a y minus 3 common to both terms, so let's factor that out again. Times 2y from here, plus 5 from here. So I think my red, let me draw a line between these so it's clear that they're different. So my red factoring here is y minus 3 times 2y plus 5. So I factored this bottom trinomial into y minus 3 times 2y plus 5. Okay, great. That's the hard part. Truly, that's the hard part. We have factored everything. Now we need to look for factors that are going to divide out to 1. In other words, cancel out. Sometimes you hear it said cancel. Really what we're doing is dividing out because it makes 1. So notice 2y plus 5 and 2y plus 5. Y minus 3, y minus 3. I don't see anything else that's going to divide out. So I'm going to go ahead and multiply what's left across the top. So I get 3 times 2y plus 1. And across the bottom in the denominators, I have 5 times y plus 6. Now that's a perfectly acceptable answer, but we could also distribute if you want. You could distribute the 3 and say, well, that would be 6y plus 3. And distribute the 5 and say that would be 5y plus 30. So either one of these answers, these are equivalent. And that is what you would get when you would multiply those rational expressions.